Okay, part two. This wasn't too bad, this one. You were probably okay with this one. Just be careful with that, though. That will cause trouble, actually. Ln of 2x, for example, it doesn't differentiate to 1 over 2x. It just differentiates to, well, chain rule, differentiate inside the brackets, you get 2. Differentiate then ln of stuff, you get 1 over the stuff. And so it actually differentiates to 1 over x. In fact, another way of looking at it is it's the same as ln2 plus ln x. And so when you differentiate it, ln2 goes to 0 because it's just a number. And so you get 1 over x. And so, yeah, this one's going to differentiate to, well, using the chain rule, differentiate within the 8x, you get 8 times e to the 8x. I'm sure you've done that kind of thing before. It's one of the first things we differentiate. And then plus 1 over x, and it's done. Okay, next one, pretty kind of standard stuff. These can be quite confusing though. They can get the better of you. I know what you mean. It's not simple. So cross-sectional area of the rod is increasing at this rate. Now the units, look at the units. This is dA by dt because it's area with respect to time, and that's 0.05. We want dx by dt. So I guess we're going to have to use dA by dt as that's what we've got. And we need to times that by, well, we need to get rid of the dA, so it needs to be over dA, and then we need to magically make a dx appear. So let's put dx over dA. How are we going to find that? Well, what is the cross-sectional area? It's that. And that equals pi x squared. So dA by dx is 2 pi x. And so all we really need to do is dA by dt, which is 0.05, times by dx by dA, which is 1 over 2 times pi times, the radius of the rod is 2. That's my x. Plug that in, and you get 0.00398 centimeters per second. Yeah, as that's the length. Find the rate of increase of the volume. Well, next is 2. Okay, so we're looking for dV by dt this time. Now, we're dealing with volume here, and it did tell us the length of the rod is 8x. And so the volume of that is pi x squared times 8x, which is obviously pi x cubed times by 8 pi x cubed if you like. And so dV by dx, you always have to differentiate these things, is 24 pi x squared. And so we're looking for dV by dt. Well, probably a really easy way to do it would be dx by dt and multiply that by what you've just worked out up here, dV by dx. We don't even need to do a reciprocal on that this time because the dx cancel and you just get dV by dt. So this is 0.00398 because we already knew that from the last question, and then multiply it by dV by dx, which is 24 times pi times by 2 squared, and that comes to, I think, 1.2 centimeters cubed per second. I'm getting some of these numbers from just the mark scheme, which is on the right hand side of me, so if the calculation's wrong, I'm sorry. I'll make a note of it in the notes, but hopefully the mark scheme's correct. Okay, so what am I going to do with this one? Y equals 7 plus 10x over 7 minus tan x. I need to show it's always positive. This is harder. You probably won't like this, but it's at least, how can you get some of the marks here? Well, this is a quotient, so we need quotient rule to differentiate it. So low d high, now that gives us low. The high just differentiates to sec squared x minus high d low. Well, that's 7 plus tan x this time. And the bottom differentiates to minus sec squared x. So that's going to become plus sec squared x times by that bracket over the square of what's below, so over 7 minus tan x all squared, and that's dy by dx, sorry, not y. Okay, how can we simplify that? Well, we can notice on the top 7 sec squared x plus 7 sec squared x, that's 14 sec squared x, and on the bottom you've got a square. Yeah, at this point you've basically finished. You just need a couple of sentences saying the top and bottom are squares. So greater than 0, they said earlier tan x doesn't equal 7, so the bottom can't equal 0, and sec x actually never gets to 0, so this is actually strictly greater than 0 on top, on bottom. Hence dy by dx is greater than 0 for all x which we're interested in anyway, for all x except x equals 7, because that was banned. Tan x equals 7. Yeah, we'll just write down that, hence dy by dx is greater than 0. That should get us the marks. Okay, what we got next? 8. Prove that for all positive values of a and b, this is true. This is hard. This is hard, isn't it? This is definitely a hard question. No question about it. If you don't get this right in test conditions, I won't judge you. Yeah. Okay, right. What are we going to do here? Well, it did say A and B were positive, so we can times it across. Oh, and by the way, I'm going to do a proof by contradiction here because I quite like it. Let's assume that this, because we're trying to prove that it's always greater than or equal to 0. So assume that is less than 0 whilst A and B are positive. Okay, I'm going to point out as well that A and B are positive, so I can times this over here. And so 4a squared plus b squared is less than 4ab. What I'm trying to do here is derive a contradiction. Yeah, and that's not easy to do. I suppose I'm going to take it onto this side. And then you know what? And this is hard to see, but this actually factorizes into a perfect square. Because if you've got 2a minus b and you square it, you get 4a squared minus 2ab minus 2ab, which comes to minus 4ab, plus a b squared. Let me do it in a grid. That's quite hard to see. 4a squared, a b squared, minus 2ab, minus 2ab. Now, when you've got this is clearly a contradiction. For exactly the same reasons we had up over there. Yeah, this is clearly a contradiction. Unless you could have 2a minus b equals, no, because it's strictly less than 0. This is never true. This is clearly a contradiction for all a and b. And so you might think, when you look at part, let me quickly explain a quirk here. You might think, well, hang on a second. We're about to show that it's not true for all values of a and b, but it looks like we've proved it is true for all values of a and b. So I'm going to rub out that last sentence. That's not strictly true. The reason why this crept in, of course, was I assumed when I times it over there, I assumed that that a and b were positive, and so I didn't switch this sign. And that's very subtle. That is very, very subtle. But that's clearly a contradiction. That produces that. Now I'm going to guess, and I'm really just guessing here at numbers where this might not be true. Let's make a and b both negative, like minus 1. What do we get? Minus 4 plus 1. Is that greater than or equal to 4? No, it isn't. I'd literally just get, those were the first two numbers which popped in my head there. A is minus 1 and B is minus 1. Yeah, I thought maybe if they're both negative, it won't work. Let me just check that actually. Does it not work? Minus 4a over minus, oh no, hang on, no, this does work. Yeah, I was going to say, because actually that problem, when I times the a and b over there, that would still be positive. I think I need one negative, one positive. But yeah, when I chuck in these two, it actually fails, does it? Well, the thing holds, if you see what I mean. So I didn't find a counter example, because I was thinking, no, minus 4 over minus 1, that's actually positive 4 plus a positive 1, and so that is actually going to be true. So my first effort, no, but that's okay. We just guess again. I think it's going to be 1 negative, 1 positive. Now let's try. A is minus 1, B is 1. Well, now we're going to get over here minus 4 over 1, so I do get genuine minus 4 this time, not a minus 4 in my head. And I'm also going to be doing take away 1 over here, because minus 1 divided by 1 is minus 1. And is that greater than or equal to 4? No. Yeah. So no. E.g. A is minus 1. B is 1. Keep wanting to put B as minus 1. Then the left-hand side is minus 5, which is not greater than or equal to 4. There we go. Hope that was useful. Yeah, quite hard, that last one, though. It really is. Don't worry, you have my sympathy if you found that difficult. Okay, well, thanks for listening. Bye-bye.